Hello, welcome to Ekidel. We are a trained future civil and structural engineer. My name is Justice Umoka and I am your instructor. Today, I'll be showing you some applications on how to apply a water load on a high-rise building. For example, you have a high-rise building and then you have a water tank on the high-rise building, and then most times people confuse on the load they want to add. Is it to add the water load on the slab or how? I'll be showing you the best way to get to or to add the load on that slab. Now I'll be opening a job that we are working on for a 10-story building, which is meant for a governmental project here in my country, Nigeria. So if I look at this project now, which is this particular one here, if I open this now, which is Makodi Tower, if I open this up now and then wait for it to display, then I'll be showing you the water tank load that we added around at the top of the staircase, which I'll be showing you again the CAD file too. So while it is coming up, I'll just wait for it to come up. Then we'll now move on the um, to the display and how to add the load, okay, and the best way to add the load, okay, that is fine. So while it's coming up, I can just go all the way to let me just wait for it to come up actually, because I want it to come up. Then we can now move to show you the CAD file of the entire project. That is fine. Then also I use a 2026 Protastructure, which you're seeing here, and this is a shared license. Is not if you're using a cracked version of 2026, you might be having issues on opening recent projects and then another that. But licensed one doesn't have that issue. As you can see, I'm currently opening a project which I did um, some months ago. So why it is coming up just now, it's coming up currently, it's coming up, and then we then move on to the next what we have for today. Basically, I was basically off for 1 month, but right now I'm back. So right now, this is now the project we are working on. This is a 10-story building, and we use 2026 to model it. We have really gone back and front with the client, architect, and all that with meeting and everything. But I think we have already achieved our goal for the modeling and everything. What is left now is for the foundation, which we are still deciding to use a pie draft for the foundation because of the nature of the structure and the nature of the soil. But that's not the case for today. Today, I'll be showing you how to or the best way to add a water load, because of I've been seeing some comments that there's constant confusion on our WhatsApp group chat on the best way to add water load. So in this case, following this video, since we have that concept here, I'll be showing you on that. So with this now, I'll just go to the CAD file, and then I have the CAD file open here already. It's coming up right now. It's coming up. Correct. So this is the building you just saw now. This is the GA that we did, and this is the site plan and a very big project. So this is the GA, and this is other floors. Okay, that's fine. This card file will not be seen on our site, right? Because it's confidential. So right now on this is the GA, and then moving to what we have to done. These are the elevations for that. And then if you now look at this area, you can see that there's a water tank at the top, right? From this to this is about 7.8 meters. Yes, 7.8. Let me see. 7 point from grid to grid, 7.8 meters. Let me see. 7.2 meters. Yeah, correct. 7.2 meters. So you can see the water tank now at the top of the decking of the beam, because we like place a beam here, so you can, but you can see that the tank here is at the top here, right? And most times people confuse, how are they going to add this load on? Should they add the load generally on all the slab, or how? So I'll be showing how we added our own load on the on this particular area on our model. Okay, that is fine. So with that now, these are all the sections, but this is the only section that shows the tank. All right, These other ones are not showing the tank, they are showing the back, and that. So this other one too is not showing the tank, because yeah, but the tank is actually around this place. This is where the tank is, okay, this area. This is that side too, is not showing the tank too. Yes, but the tank is at the back, not on this area. This area is for the circular hull area. And then let me see this other line. The tank is around this area here. Yeah, around this area. And then okay, that's fine. Then if you go to the roof now, you can see where the tank is. This is where the tank is, around this place. Okay, that is fine. So with this now, we will then move on back to our, let me just minimize, let me just make it a dual screen like this. That is fine. And then we now have the Prota here. Okay, that is fine. So with this now, you can now see, I want to make it a dual screen. I want to move the Prota here. Just hold on for a while. Let me just pause it first. I want to move the Prota this side, right? And then this other one this side. Yes. So I'll come now and then click on this place back and then put Prota here. That's fine. So with this, I'll just move this one out here. So with this now, this is where we'll have the tank, which is on this section. You can see the tank here, two tanks at the top here, and you can see this is this is the model, and then you can see where we'll have our own. Let me just go again here. You can see we'll have the tank 2 at the top of this tank. Now you can see how we placed our tank. We used an area load to place this tank. You can see the load there is being displayed there, 25.5 kilonewton per meter square. You can see the load there, and having again a dead load of 2 kilonewton per meter square. Then you can now see the load. Now we didn't apply the water load as a dead load. We applied it for as a life load to get the worst condition, knowing that the life load factor safety factor is higher than for the dead load. So we applied it as a life load just to have the worst scenario, and then we now applied 2 kilonewton per meter square as the weight of the tank. So in that now you can now see how we modeled for this tank. You can see the both tanks here. These are the both tanks. Yes, this one is tall because this is the architectural model, but what we are considering fully is not how height it is, how height our own model should look like, but it's actually the weight. You can see our weight here. And then now when you want to, now let me now zoom back to how it is now. Now when you want to apply a water load or a tank load on a slab, you can see how we placed our slab. We have to place a beam across the place, knowing that on this other side there was no beam that was showing here. It was showing just the slab, but no, this is not safe, so we have to run a beam which is structurally safe. So we have to run a beam here, a beam here, a beam around here, and a beam now crossing two of them, which you saw just now on my screen here. Correct. Okay, on my screen here. So this is the, so now you can see the beams too. So right now, for you to now model a water load correctly, you have to use area load to apply that. That is, if you know the exact point where the tank will be. And most times the tank that is on the roof are always in a constrained area, like they don't have enough space. They are always constrained either around the staircase in a very short place, where once you put in the tank there will be no more space for the tank to shift. Okay, that is fine. So in that particular scenario, you can use area load to place the load directly at that particular point. And how do you get your area load? By going to the loading tab here, and then you go to point load, line load, and area load tab, and then you will get your area load here by clicking on this, and on that put in your value. Okay, then come to that point and insert it. You get a point based on your architectural drawing, which is the CAD file. You get it. You get the point there. Place it there. Now, if it is if the area that you're placing the tank is not constrained, right? Because right now, if they place that tank here, what will be left is just around 200 what millimeter around here and around here. So the tank doesn't have any place to shift. So that particular point becomes the place where the load will be on the structure. So with that kind of place or with that kind of scenario, it is best to use area load to center the load at that particular what area of that particular slab or something. So now, but if you have a very vast place, which there is every tendency that the tank is going to shift, all right, shift. So with that, it is best to place the load on the slab, So had it been, let me say, the tank was to sit around somewhere of this whole panel like this, right? There's a tendency that the tank will shift because this panel is bigger than the tank, more than times 3 of the tank. So in that particular scenario, instead of me to use area load to locate that point, because during the construction they might choose to shift the tank, and if they shift the tank, knowing that I considered a load at that particular point, it will cause an issue. So in that scenario, I will load this entire slab with what? With the load of that water, which I've done calculated, right? I'll place the load there so that if at any scenario during the construction they like shift the tank to anywhere, the slab and the beam around that particular panel will still carry the load perfectly. So this is my own take. Let me get your own take on the comment section how you place your own load. Okay, that is fine. But this is how I best know how to place load. Okay, but let me know your own scenario and let me know if you have any contra opinion on what I've said so far. So thank you so much and God bless you. In time coming, we will be we will use this particular building plan to make a video of this 10-story building. Okay, but we are using basically we are going to use a pie draft for this because currently there are so many reviews going on this building. Because why? Because single pies cannot be able to work on this particular structure because of the columns. If you put a single pie, they are causing clashes. Okay, causing clashes with each other. So in that, we are going to use a pie draft, and on this circular area of the building, we are actually going to use a pie draft, but the pies are going to arrange in radii, right? In radii. Okay, which I will be showing you guys later when we are done with the whole design of the foundation, because we are done with the superstructure. You can see the design here, analysis here. We are done. We are already done with the drawing and detailing for this superstructure, but we are waiting for the final meeting that we are going to have with the client engineer and with Ekidel. Then we will then now finalize on the foundation, because the client engineers are still saying that we can still use a single pie to achieve this, but we have sent so many reviews of so many suggestions from what we have done so far, trying to make sure that single pie works, but it's not really working. So we send them the final review, and then they should make their own suggestion. And then if they come up with that, we can then apply it, which we are sure that single pies are not going to work. What I mean by single pies, not by just one pie. No, I mean by single, one pie cap for each of the columns. All right, one pie cap for each of the columns are not going to work because of the weight or the load coming to each of the columns based on the number of stories. That is one, and then also how close the columns are. Now, don't think these columns are very close. They are 6.5 meters apart from each other. All right, so they are not really close to that much. So, but even at that, we are still having pi to pi spacing issue. Not that they are clashing, but by the time you measure the distance between each of the pi, they are less than 3 times the pi diameter or 2.5 times the pi diameter, which if you can construct it, it will going to cause a crack during the piling and the casting process of each of the pies. There will be crack inside the ground and you will not know. And before you know it will cause a collapse because there is already a crack on each of the pies that they've already piled. And that will happen, those cracks will happen when your piling or when your pie spacing are less than the required standard, which is 2.5 times the pie diameter or 3 times the pie diameter. So with that now, we are going to use pie draft for this particular 10-story office building for the state government. But until then, until we receive the final review from the engineer's client, from the client's engineer, then we will then proceed for the pie draft. Okay, that is fine. Okay, so that's what I have to for you guys for today, which is to show you guys for that. Now we are coming up with like I said, I was off for 1 month throughout September, and I came back not too long this month. But yeah, and I was really on a very serious project. So on this now, I have a video for you guys for a 6-story not this one, a 6-story hotel building that we are currently performing in Cape Town. It's coming up. I don't know. It's coming up. And we are currently using just 12 columns to carry this structure. This is a 6-story hotel building we are doing for a client in Cape Town, South Africa. So, and we are using just 12 columns to carry this structure based on what the client and the architects agreed during our last meeting before we started performing this particular project. Okay, that's fine. So we are currently making a video for this particular structure. So if you're from Cape Town, Africa, watching this video, Ekidel is in your town and we are in your land. So we will be posting videos about this particular structure, which is this 6-story hotel building. Although this is actually a course video that we'll have on our channel, which we have just created, although we have not yet posted the course video yet, but we are about to finalize the course video. But we will also be teaching you guys how to because most of these column spacing are more than 8 to 10 meters apart. They're 6 meters apart, 6 meters, 6.8, and then 7 point something meters apart. So but we will be teaching you guys how to, and we also have a 2-meter cantilever. Let me just show you guys on that right now. So this is the 2-meter cantilever, 2.2 meter cantilever. You can see there, 2.2 meter cantilever, which you have here. You can see them here. Yeah, correct. Carrying all the floors from the first floor down to the last floor. So basically, this video is to help the younger engineers that have mastered the principle of column spacing not more than 6 meters. So right now we are trying to push you guys forward to get new experience to be able to design structures of buildings having column spacing more than 6 meters. Okay, that's the next stage we are going on now. If you're new on Ekidel and you're a student watching this video, to avoid confusion, please go and watch the video that we made 2 years back, 3 years back, so they can have a basic understanding, because most of now that we are moving to a higher level, we will be skipping some parts, or we will be explaining in an advanced way, although we will still try to explain lower. But once you're making these videos, once you hear this is a pro version, that means that is for higher engineers that have passed through Ekidel for the past 2 years watching our videos and have mastered the principle of 0 to 6 meter spacing of column maximum. Now we are moving you guys to a higher spacing, 7.5, 8.5, 9.5, 10 meters. I have designed for 13 meters beam before. That's column spacing, 13 meters That's a bean span. Now there are principles that you are going to master to be able to design for all this. Now we are moving you now to the next level. So we are coming with these videos. Okay, this is the first video we are doing on this series. Okay, that is fine. So see you on the next video. Right, that's fine. Thank you and God bless you. I'll be with you for a very long time, for like 2 months. Yeah, that's fine. And I'll be active fully on the WhatsApp group. Yeah, I have not been active for the past 2 to 3 months now on our global WhatsApp group. So if you have not joined our WhatsApp group, you can get the link on the video description. Yeah, I'll like drop it for you to join. That is fine. So thank you so much and God bless you. Now, please, if you like this video, like it so far, and also know that the major aim of this video was for the water tank load. So please drop your comment down on the comment section so far. Do your research and drop the comment section, like a comment or your own opinion on how to load that. All right, everyone can learn from you too. That's fine. So thank you so much and God bless you. We love you and bye for now. Bye then.